Howdy, hope you're doing well. Would encourage you in this video to actually pause it now and work through these problems and think through it on your own here. And then I'm going to take a look at kind of a little intro if you're stuck. So feel free to pause it, work on it. If you're going great, just keep going. If you need to watch the next intro part before you work on it, that's fine too. All right, so this has us creating a function out of the sequence. And what I mean by that is this picture is just a sequence. It's just a list of items. In this case, it's a picture, really, a figure. But then when they start putting these figure numbers on it, it really starts to turn it into a function. And so I can think of this as my x and my y, the figure number here, so on. And then the number of dots is my y. And so you see it starts with 4, and then it goes to 7, and then 10, 13, and 16, and so on. Sorry, that's not 16 for n, but you can see the pattern. And so then the question is, can you come up with an equation or expression to explain this here? And so if you haven't, I would encourage you to pause this now and do so. There's lots of different ways of coming up with this expression here. I find that a lot of students just are maybe comfortable or familiar. They start looking and seeing this is going up by 3 each time. And so they've learned over the years that that means it's 3 times n. And then they kind of go back and check and say 3 times 1 is 3, so that's not quite right. It's 1 less. 3 times 2 is 6, 3 times 3 is 9, 4 times 3 is 12. So each time it's always just 1 less. So I want to adjust it. I want to add 3n plus 1. And that's fine. That's a great way to look at it. But what I really want to highlight is in number 2, this is a really key thing. And if you're teaching young students to help them see the connections between the diagrams and the equation, is going to be really helpful for them. So how does this connect to this? How does this connect to this? Well, it is true that it's equal, but it's a little bit deeper than that. If I take 3 times 2 plus 1, there's a relation between these numbers and this figure. Do you see it? I encourage you to pause and think about it for a moment. Hopefully you're able to see this, but you can think of this as 3 sets of 2 plus 1 center arm. 3 sets of 2 plus 1 center arm. If you look at this, this is 3 sets of 3 plus 1 center. 3 sets of 4 plus 1 center. And then if we have the nth term, which isn't listed there, but if we had the nth term, we'd say, well, it's 3 sets of n. We don't really know how long those arms are going to be, but there's going to be n in there, plus 1 center one. So that's 3n plus 1. And you notice we didn't rely on the table at all in that explanation. We just thought about the figure. There is another way of looking at this that also relies on that. So if we take a look at 3 times 2 plus 1, we could actually think of this as successive circles. We have 1 in the middle. My next circle has 3 more. If I skip ahead a bit, 1 in the middle, plus 1, another circle of 3, another circle of 3, another circle of 3. Sorry, my circles got a little crazy there. But you can see I have 3 circles of 3 right here. 1, 2, 3, plus 1 center. So that gives me 3 n plus 1. And this is really helpful and useful for students in finding patterns, is looking at the structure of the diagram and relating it to the equation, rather than just looking strictly at number patterns. Now, number patterns are good, and we want to see the connections between all three. So I wanted to point this out, make sure that you saw it, and I think I'll end the video with that. So as you are working on class activity 9Z, see if you can use that. If you're still working on class activity 9Y, see if you can use the same idea in those